So, I'm talking about Space 4.0. What does it mean? Space 1.0, this is and was astronomy. Still a very strong instrument to look into space, to look into, to make the first steps of humankind to go in space. Space 2.0, that was the race in space, you know it, about the Americans and the Soviet Union. So the first man on the moon, that was of course Neil Armstrong. The Russians went to the moon also, but not with astronauts or cosmonauts, but with a rover. And they also brought some material back, and I could talk about Alexei Leonov, who was the first man doing an EVA, an extravehicular activity, meaning outside the capsule, very special story. This is Yuri Gagarin. This man is well known, not because of his birthday, which is the same as mine, but because it is John Glenn, the first American orbiting the Earth. Alan Shepard is not so well known, was the first American flying to space but not orbiting. This was the space race. In this space race also animals played a role. On the Soviet side, a dog, Laika, very well known. On the American side, it was a monkey called Ham. He survived, Laika did not survive, but some other dogs survived. What did Europe do at that time? They sent a cat into space. It's a true story. This cat, and I have to tell you the story, a tomcat was selected. His name was Felix, and on the day of the launch he disappeared. So a female cat had to substitute him. She was brave enough, so this shows. And if you look to this picture, this is not something wrong in the picture. These are some sensors in the brain to measure what happens, and the cat survived this flight and lived for several years happy. So, maybe you know this picture, very famous picture, a little bit more than 50 years old, Apollo 8 surrounding the moon for the first time with some living parts from the Earth? No, with humans. Why not living parts or living things? Because just a few months before that, and nobody knows about it, I learned, maybe you know, but the Russians, Soviet Union, sent also something around the moon. And that was interesting because it was in the Cold War, and they had to organize that they don't make a collision behind the moon. And it was with two turtles. Two turtles were flying around the moon. I did not know the story, but of course you all knew it. So this was in 1968 when it happened, and it was a very successful story for the Soviet Union, not so much known in the world as such. So, at that time, this was what Germany was doing at that time. They produced a movie called Orion with an American commander, an Italian officer, with the nationality of this guy was not even clear, Japan, Turkey or Azerbaijan, the engineers from Sweden, Jonathan Leclerc from France, and for me, as a man, this actress Eva Flug as Tamara Jagelovsk from Russia, security officer. This was a mission. In 1966, the others were thinking about Cold War, and Germany was producing a movie with all these different countries. At that time, around that time, the first origin of ESA happened. Two organizations were formed, and they were merged, and out of that we got the European Space Agency, ESA. Since 1975, our convention is not changed a single word since then, so it's still exactly the same organization. Space 3.0. This is some steps for global cooperation and space applications, and the International Space Station with the Americans, the Russians, the Japanese, the Europeans and the Canadians. A very important step to go ahead. So now we are moving, I said different applications. What does it mean? That we are really tackling global challenges. You see here a full list. I will not go through the list. And you might have your own priority list. I don't discuss about that. What I say is each and everything which you see here can be tackled by space. Even, for instance, health. With astronauts in space, we learn about the immune system and other things. But there is one thing more, and this is curiosity. That's, to my mind, the strongest driver of humankind, stronger than just the question of the next iPhone or whatever. That is curiosity. And space is really helping with applications, with science and exploration to support curiosity and to give this feeling of curiosity also to the next generation. ESA today is a an organization with 22 member states. We are not part of the EU. We are an independent intergovernmental organization. 20 members of us, 20 member states of ESA are at the same time member states of the European Union. We have Norway and Switzerland in, and just to say it already, the British will remain a member state of ESA. So it might be that they are leaving the European Union, so they decided they will remain with ESA. This was a very early decision. But there are some buts, but you should not have a boring evening, so I don't tell you all the buts. Now, there are 4 programmatic pillars now in ESA. We are working on science and exploration, looking to the universe, looking also with humans in low Earth orbit. We make safety and security. I come back to that one. We are doing applications, meaning Earth observation, navigation, telecommunication. We are also, please go. Okay, so we are doing developing new launchers, we are developing new technologies, and of course also operations is there, and we call this enabling and support, because you need these things to have some space missions, otherwise you cannot go into space. Competition is a driver, we all know that. Competition is important in sports and other areas. Competition is a driver, it makes us better. But at the same time, we should understand that cooperation is an enabler, and we have to think about both at the same time, to accept competition here, but to do cooperation there. And this is the sense of ESA, because with our 22 member states, of course, we have some competition between the different member states, but at the same time, they are working together, because some of the missions they cannot dare to do alone with one, or cannot afford with one country only. And then, this is now coming to Space 4.0. What does that mean? We have a change of motivations now. We are not doing it because of Cold War. We have applications and all these things. We have more than 70 spacefaring nations, and sometimes industry or universities have their own space missions. We have different contents, really broad variety, not only sending a man or a cat or a dog into space or to the moon. We have therefore also different roles, what agencies have to do, what industry can do, what universities can contribute. And that means also new technologies. And on the right hand side you see a long list of things. I would just mention maybe this one, spin in, spin off. Some people believe that the Teflon pan comes from space. It does not. But for instance, the smoke detector, which we have here, in the unlikely effect, for the unlikely effect, we have here a smoke detector, and smoke detector comes from human spaceflight, because after the catastrophe with Apollo 1, where 3 people died, the smoke detector was invented, and now it's used everywhere. This is what we call spin-off. Now we are looking also to spin in, saying we are using technologies from other areas and bring them in space. One example is a so-called 3D printing. This is a typical technology. More things here, I will not go into detail, but look to the last line. Digitalization, this is something where we are now also in space, and artificial intelligence. These are new areas we are now using. This is the nicest picture of our Earth I ever have seen. It's Saturn, and this is us. This is us. It shows a little bit the importance of us. This is a blue planet, and of course the nicest place is over here, we know that. But anyhow, this Earth is endangered. We are in a dangerous situation with all the climate change and all of these things, and I don't have to explain to you all this because you are witnessing it here with forest fire, and also the same which happens with the dry period you had in South Africa for a long period. So this is, for me, also a picture of Saturn and the Earth, telling us a little bit to be a little bit more modest with our understanding the giants of this universe. I'm quite sure we need the universe, we need our sun, we need our Earth, but I'm not so sure whether they need us, the other way around. Now what we have to do also, we have to look into the future, and when some people have smart ideas, we should always have a look into it. Michael Faraday, the name Faraday, most of people have heard about it, Faraday cage and so on and so on. He, at a certain point in time, invented a method how to produce electricity by induction. Okay, this is a machine he invented. And as well, he had he had the visit of a politician. That happens sometimes. And then the politician, it was the prime minister, this at least the legend is saying that it was the prime minister, was asking him, what is it good for? And he had no clue. So what he said was very smart. The microphone, he said, no idea, but you will tax it. That means that we also have to look to new applications, new technology, digitalization, artificial intelligence, without always saying, what is it good for? Let's develop it, let's see what it's good for, and then we will see and we will find and there will be solutions. For instance, quantum technology. I could tell a lot about quantum technology, quantum entanglement. This is a new world. You have maybe you have a clue, but I had no clue when I got this information. But we don't have time today, unfortunately. Maybe tomorrow afternoon we make another lecture about just quantum entanglement. Dark matter. You know what dark matter is? If somebody of you know it, tell it me. I would like to Nobel Prize because nobody knows it. Nobody knows it. And nobody is perfect, so who is perfect knows about also dark matter. Dark matter. The idea of dark matter is the following. I have some scientists in the room, so you are quiet right now. Don't interrupt me, even if it's wrong. If you have a galaxy and you have some stars in the galaxy, then according to our normal calculation, the galaxies and the stars which are far away from the center should move slower than the ones being close, because otherwise they would fly away. The gravity forces cannot hold them back. That would mean we would expect that the speed of the stars far away should be smaller, lower than the ones being close. However, as this picture shows, the reality is different. And as we do not know what is happening, we call it dark matter. Maybe there is something like dark matter, and I know that our scientists are looking for that, but maybe there is no dark matter and it's just a question of our calculation. I don't know, but our scientists are convinced that there is some dark matter. So, and if we understand what dark matter is, who in this room is sure that we cannot use it for the next generation of some technology on Earth? I don't know. For instance, Albert Einstein. 100 years ago, he formulated the theory of relativity, the general and the special one. You remember the formula. So, the special theory of relativity says time is slowed down by velocity. I checked it with my car on the German highway, no effect. The second one, general theory of relativity, time is slowed down by gravity. I was today in an airplane. The airplane, of course, lower gravity. I checked my watch, no change. So maybe it's wrong. And what is the benefit for society if we have this? Where is the advantage for you? Why to pay this guy, who is that now? Why to pay him at that time to do something which is worthless? It's not worthless. You are all using it. Because satellite navigation works with satellites which have clocks on board, and they are far away from the Earth, about 24,000 kilometers, so the gravity is much smaller, so that means the second one is relevant. And they are really fast, these satellites, so the first sentence is relevant. Unfortunately, these two effects do not substitute or diminish each other. Without knowing the Einstein theory of relativity, the error of a satellite navigation would be 500 meters in just 1 hour, so it would be worthless. So therefore, let's also give people, scientists, the idea to study dark matter, dark energy, black holes. Fabio, what else? Gravitational waves.
Gravitational waves emitted by black holes?
Yeah, for instance. My specialty. Okay. Because you don't know. This curiosity-driven work has some value, and if not, we understand better what the world is. This is also an advantage. And therefore, the satellite navigation is depending on basic research. This is the European system. You know, there's also an American copy called GPS. And if you have a modern smartphone, then you can already receive also the Galileo signals. This is a screenshot from my mobile phone, so it's working. It's already in really working, and you can get the data, and you get with your smartphone both the GPS and the Galileo data, and that makes your precision even better. So it's not competition of the two systems, it's a cooperation of the two systems. We had one launch of 2 satellites for the Galileo system, and unfortunately the rocket had some mishap and brought the satellites onto the wrong orbit. Normally you would like to have the satellites on a circular orbit around the Earth, constant distance, constant velocity, constant gravitational force, perfect for Albert Einstein. And in this case, the orbit was wrong, was an elliptical orbit. Now we got a blame in the newspapers, ESA had a failure, blah, 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 blah. In fact, it was really good, because now we had 2 satellites with very high precision clocks, 8 clocks for here, for there. Nobody would ever give us money to do this experiment, to send just some clocks into space and nothing more like that. So with this method we could justify the prediction of Albert Einstein by factors better than in the past. And, as I always say, there is no word in the Bible that you cannot use satellites for satellite navigation which are not on a circular orbit. No word. You can check it. I checked it twice. And therefore, yes, it needs some more software, blah, 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 but it's working. Now what we are doing in ESA is we try to realize a seamless chain of innovation from very fundamental research, as Albert Einstein, to the market, to the public applications. There might be in between some time difference. Consider Albert Einstein, 100 years. But what is important, not to forget about the knowledge, not to stop over here, not to stop to feed the system with new ideas over here. Science is important for this. Science is always the basis for future developments. Of course, here on the right-hand side we get also more and more commercial activities, fine. And this is also the shift of Space 4.0 from public to commercial activities. We are doing this not only in space, one line over here might be space, but there are other areas, agriculture, medicine, entertainment, whatever. And to combine them in all directions, this gives us future development possibilities. And we have some special instruments, and we are discussing here with SANSA right now about why not setting up what we call an ESA lab at a university in South Africa. Why not setting up something like an ESA Business Incubation Center together with SANSA in South Africa. So we are looking into these different fields to go with. As I mentioned, science is really the basic for everything what we are doing, and science is in ESA a bottom-up process. So the scientists decide, not me unfortunately, the scientists decide, or maybe it's good for the science, what to do. And we have a lot of different missions. We have, for instance, as I said, dark universe, dark energy, dark matter. We are looking for exoplanets similar to the Earth, with characterizing them. We are on the way to Mercury with one mission. We are looking to gravitational waves, and also with NASA together to the universe as such. This is the launch of Bepi Colombo, so it's really the launch. This is not a rocket, so that's a crowd. This is just a scaled. No, it's not scale 1-to-1 model at the entrance, but you see here this was the launch of Bepi Colombo in October last year. It takes 7 years to go to Mercury. It has 3 spacecrafts. One is, let's say, the engine. One is a European spacecraft, and another one is a Japanese spacecraft. So we are working also with international partners. And it is electric mobility because we have an electric engine on board, so it's not with chemicals but electric. Xenon, the gas, xenon is used. The world production of xenon is 600 kilogram. We are using for this one single spacecraft 585 kilogram. So if you get no car with xenon light now, you can blame us because we put it in orbit. So it's about 9 billion kilometers. This is also a world record for electric mobility if you look to the cars on the street. So, and we do not refuel it, or we recharge it. We have some selfie, some first image. We see here that the solar panel was deployed, the antenna was deployed. So we are on the way to Mercury and it will be excellent discussion and results later on. We are trying for the gravitational waves to, as I said earlier, to have a mission in the early 30s, but now we are trying to combine it with another mission, which is called Athena, which looks to hot gas structures and supermassive black holes, because there is some idea about links between gravitational waves and supermassive black holes. So the gravitational waves exist always, Fabio, correct me if I'm wrong, if there is some big acceleration of masses. So now you have no big acceleration but a big mass, and some acceleration. So maybe you could feel the gravitational wave. There was some. Did you ever think about, I know you have some problem with water, especially in Cape Town, did you ever think where the water comes from? Of course, it's, you can directly get it, but where does it come from on Earth? The Earth was in the past so hot that there was no water at all on the surface of Earth. And then the scientists started to think, and the first idea was comets. Yes, comets are frozen material. They brought the water to Earth. And therefore the idea was simple, let's go to a comet. So we started a mission called Rosetta. Look to the water. There is water. Fine, water. We found the water. But then we compared the hydrogen, the water on that comet with the water on Earth. And on Earth, the relation between what is called heavy water and light water is more or less constant. Whenever you have a bottle of water or whatever, it's more or less constant. But this comet has a totally different ratio. So we know that this comet alone never brought the water to the Earth, but we don't know whether other comets brought it. So it's an open question, and scientists love always, if at the end of the day, they have more questions than before, because this is going forward. Now I will show you, now I will show you also some difference. You know this American ESA, so it's called NASA. You will see the comparison between the two. One is, the sending Curiosity, a rover, to the surface of Mars after a flight of 6 years. And then the control room, you will see the control room, I hope we will also hear it. And then you will see the control room in Darmstadt from the European Space Agency after the trip of 10 years to the comet Churyumov-Gerasimenko. First, so it's about the excitement level. Huh? First, NASA doing touchdown of Curiosity. There is no sound. Can you switch it on? Okay, you see it anyhow. If you cannot hear it. There it is. Okay, now after 10 years, Darmstadt. Same control room, a bit different if you see it in a minute. That's all. So, when we went to this comet, we had a camera on board, and this camera makes pictures just of gray, dark gray, hyper dark gray, black, and so like charcoal. And so you could say 50 Shades of Grey or something like that. And this camera, some guy had the idea, why to use it only in space? We can use it on Earth. And this is a link to South Africa because of early warning for forest fire. So he brought this technology back to Earth and is looking over the forest, and if something grey comes out, the camera can decide whether it's forest fire or whether it's fog or whether it's just vapor. So and the company created that, and they are selling now hundreds or thousands of these cameras. So it's a useful, so why only to know something about the water on the comet? Here you also learn about something for the Earth. We are on our way to Mars. Mars is the next planet which is interested and which you can reach in a certain period of time. So we are having one mission which is surrounding, is orbiting the Mars and looking for methane in the atmosphere. And when we planned this one, we said, okay, we can already try to land on Mars. Difficult to land, because we need this one, this spacecraft, to later on have it as a relay station for this rover, which will drill into the surface of Mars to look for life. So we did this, and this small part tried to land, so it's very difficult. You have an atmosphere, you need the heat shield. Then you can use a parachute. You have to separate the heat shield because it's heavy. Then you separate the parachute and then you start the engine and then you have a soft touchdown. That's the plan. We were very excellent until here. We got all the data, everything was fine, but then the computer stopped the engine because the calculation to the computer said we are already some meters below the surface, and it makes no sense to have an engine below the surface. But it was still 3.7 kilometers, so we had a touchdown, but not a soft touchdown. Now, what would I like to say? This one was just a test case. We have all the data, we know exactly what our mistake was, we will do it better next year, so we learned. Fine. Now I go to another South African, Elon Musk. You know his name? He is trying to make reusable rockets. And his third trial was to land on a small ship. First 2 times he failed. So here you see the third time. But remember what I said here. Our main spacecraft is in orbit of Mars. It's functioning very well. But now let's have a look to the other. This was, first of all, what the German, it's a British newspaper said. Schiaparelli Mars probe crashed, making it 2 failed landing attempts from either. They are right. We failed. Now you see this trial of Elon Musk to land on this tiny box. It's really impressive. So, yes, very fine, but there is sometimes a but, and therefore I selected this movie, because there is a but, and the satellite was in orbit, so that was the main task, as in our case. The satellite was in orbit, our test case failed, his test case failed. Now let's have a look to the newspaper. The German newspaper said, SpaceX failed again with landing trial, launches of those crash landing. They are right. American newspaper. Falcon 9 almost landing. But it needs more touch. And Elon Musk, as another American you know, is always sending tweets. He was saying, rapid unscheduled disassembly event, ship is flying, minor repairs, exciting end. Think about what would happen if I would say, rapid unscheduled disassembly event, Mars is fine, no repairs, exciting end. Big data, you all have heard about big data, right? And normally people think big data, that must be a full room full of data. Not always. If I have Walt's credit card and the type of card, the number, your name I have anyhow, the expiration date of the card and the security code on the far side, I have his money. So this is big data, just 5 data and I'm rich. So therefore, big data means for us to combine things from different sources. So for instance here, that's the highest mountain on the Earth. It is not Mount Everest. It is Hawaii, Mauna Kea, which is about 10,000 meters high, but you cannot see it because most of it is underwater. So this picture is using underwater data and data coming from satellite, in this case satellite data, and suddenly you see the beauty of this mountain. And this is also big data, putting together data from different sources, and by putting them together, you get some better understanding. Where are we using it? Especially when we're looking to the climate change of our Earth. Because only one data is not enough. We have to look to very different things, for instance, to the methane, to the evaporation, to the heat, to the water vapor, to the ozone, blah, 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 to all of this. And if we put it together, then we really see climate change is happening. And it is even happening when the American president believes that because it's cold in the US right now, he believes climate warming is not happening. He's wrong, the other way around. Because of climate warming, it is cold, because the whole atmosphere is changing. There was another person in politics, John Kerry, I think you know the name. And when he saw this data about the sea level rise, and you see here over many, many years from different satellites, he was in Paris and he said the following. I know there are still a few who insist that climate change is one big hoax, even a political conspiracy. My friends, these people are so out of touch with science that they believe rising sea levels don't matter because, in their view, the extra water is just going to spill out over the sides of the planet. Now, this big data, I'm coming back to big data again. This is also big data. This is the picture of the Earth. It's not Earth observation because you don't see the continents, even the most beautiful country, you cannot see it, it's dark over here. But you see just dots, dots, dots. Each and every dot is a ship. Ships are sending signals, automatic signals, I'm here, I'm here, I'm here. The good ships only, yeah? Not the bad ones. Now if you look at the same time with another camera to the sea, and you compare the data of this signal with, now you look here, you see a dot, you look there, yes, there is a ship. You look here, you see a ship, oh, there is no dot, that means this ship is not a good one. And by that you can find even ships which are hijacked and all of this by comparing these data one with the other. So you have to do that automatically. Gravity, an interesting movie, I don't know who saw it. Raise your hands. Okay, I see the men like me, they saw only Sandra Bullock. There was another guy over there, he is normally selling Nespresso, but he was also in this movie, George Clooney. And this situation with this space debris is it's a serious one. And we know this because we have around the Earth a lot of debris. Right now we are counting, or we think about 750,000 particles of a size of at least 1 centimeter. And all of them are flying in vacuum. So what do we need? A vacuum cleaner. Okay, we need a vacuum cleaner for that. Now you can say, this is not real. A picture of one of our satellites, Sentinel-1A, in April 2014, the same picture 2 years later, and you see here an impact of a very tiny particle destroying part of the solar panel, and we cannot move away just for a small part. So we have to do something about space debris. And another issue is if rockets are launched, they throw again away some of the particles, some of the parts of the spacecraft. So ESA is clean, we do it really very seriously, but I put this picture just to explain the case. And then some of these things fall down. From a probability point of view, no danger at all. But if you tell the farmer owning this building, probability was 0, then you get this face. Because it was it. We had another case, this is the Chinese the space station, and it was not any longer controlled, so it re-entered into the Earth's atmosphere, and these are the last orbits, and the red parts over here mean where are people living. And you see here, you were lucky at that time, very many people, and from there to there, where it finally came down, it's about 10 minutes, so it's really something we have to take care of. And also sometimes collision happens between satellites. Here it happened between a Russian and American satellite producing again space debris. So it's a serious issue because space is an infrastructure we are using, so we should have it clean. This is also your knowledge. Okay, it's not a satellite, it's not a human space flight. Okay, it's Elon Musk sent this in space, but I'm a little bit, I say, why? Okay, that's just my opinion. Okay, some others are producing mega constellations to have a better coverage of the Earth, and if you ask them can you afford all these satellites, they say we are reducing a little bit the reliability. I say, how much is a little bit? They say 10%. That means if they send thousands of satellites in space, 10% is hundreds. Hundreds are not any longer safe. This is something I cannot accept, so we have to do something for them. And therefore, for the future, we are working right now on artificial intelligence to avoid collisions in space. Airplanes have something like that. We are looking now in systems which they are much faster, of course, but we are looking into systems like that. And we are looking also in a vacuum cleaner, which should deorbit satellites which are no longer in use or make some servicing in orbit to use them for a longer period. And this is also a danger. This is meteorites. You know it. It happened over here as well. In that case, I hope no injured person. But here in Chelyabinsk, 1,500 people were injured by that. That was the final crater, so to say. Sometimes bigger parts are coming close to the Earth. This is a big one. Okay, it's a little bit above. But you see, 30 kilometers diameter. So Hermanus would fit, huh? And these are the craters, and some are in South Africa, over here. So these are the craters which are confirmed worldwide. And also some were confirmed on the 21st of January. We had, I think you could not see it over here, the lunar eclipse, but there was a lunar eclipse, and they found out some impact on the moon of some bodies. So, and just to give you the probability, because the German, especially the German politicians are always saying, will it happen during my term? Okay, let's have a term of 5 years. Then the probability is still there that a large fireball will happen on the Earth, wherever it will be, with an energy of more than the Hiroshima bomb. So it is a danger. We have to do something. This is how the dinosaurs died out. And I can tell you, this is not a solution. Bruce Willis did it once. He will not repeat what he did. So we have to do something. We are working on that. We call it planetary defense. We are working together with NASA because they can better shoot and we can better observe. So we are trying to do something in that direction, to play billiard in space. The sun, and this is now we are really here at SANSA. SANSA in this case, not SANSA. There are solar flares coming from the sun. And this is really dangerous because it can hit our electric system. It can hit the internet, it can hit also our electric system, it can hit the satellites, the avionics, even Galileo GPS can be affected by that. And there was a big one which happened some little bit more than 150 years ago in the US. And at that time there was no electric grid, there was no internet. But they had telegraph systems, and it's said that in some telegraph stations, even the paper began to burn. I don't know whether it's true, but it's a good legend to tell about the importance. And also it happens in the northern part of Canada, and I learned also it happened also here. Those solar flares can, or solar space weather can really affect our daily life. In this case, the transformer was failed. And there's also said that during the Vietnam War, 30 marine mines in a minefield were exploded because of the solar flare. This is the story also we found out, but we could not confirm it directly. We were not there at the time, but okay. So what we are trying to do, of course, today we discussed also with SANSA how we can intensify our cooperation. And we are now looking for a satellite spacecraft putting here, L5, which is a special point where you can stay permanently. The Americans would like to go to this point, which is a balance point between the Sun and the Earth. And if you look from here to there, you can nicely see the direction. If you look from here to there, you can see the speed. And of course, if you have ground stations over here in South Africa, then you have additional information. And by putting them together, we can make a better forecast and warning, because we cannot switch off the sun, and we don't want to switch off the sun. I go to exploration. Exploration is something where we look to low Earth orbit, Moon and Mars. In 2014, the Crimea conflict started. And it was in 2014 that I was asked to come to the launch of a European astronaut with a German accent. That was Alexander Gerst. And I was really afraid. What will happen? He should be launched from Kazakhstan. I said, oh, will that work? And that was the picture I found when I was there. So it's here, this German, the European astronaut with a German accent, a Russian astronaut, cosmonaut, and an American astronaut. And they were sitting even closer than on this picture and launched by a tiny Soyuz capsule. This is excellent. Geopolitical efficiency an effect of space. We are working together, also we have some trouble on Earth, and this is a good vision and message. As I said, International Space Station. On the station we are doing research, very different types. So for instance also immune system. The immune system breaks down in space, and the immune system is very important to understand because AIDS, we have it's less, and if you look for transplantation of organs, it's too strong. So to really understand what the immune system is a very important medical question. But we are doing also other experiments with blood pressure, also with biotechnology, with new materials and so on. But there is also another aspect. This is again Alexander Gerst. He was looking down, he saw the beauty of the Earth, he explained the beauty of the Earth. He looked also down and he saw some explosions and rockets flying in Gaza and Israel. And at this time he got strong criticism from German newspapers saying he is not paid for emotions, he is paid for research. I think he is paid for emotions, and he should tell us what he sees, because our tiny pale blue dot really should get all our support. This is an Italian lady, European astronaut with Italian passport, Samantha Cristoforetti, and she took this picture showing us how thin the atmosphere is in which we live, how thin it is, we better take care of that. She shows the moon, I like that one. And she shows here a flower, she would call it a flower, I would call it, no, it's some part of the Kazakh steppe, but you see her face, she's saying, I'm back, it's so beautiful on this earth. This is a nice picture for me. He flew again, Alexander Gerst, he just came back some weeks ago. But where to go next time? There is no ultimate goal for humans, I'm quite sure. But it's difficult to go. So is Mars the next destination? To go to Mars and back takes about 2 years. Can we really afford to send a person away and he or she cannot go to any doctor within 2 years? And we have radiation and all of these aspects in addition. And it's different whether you go to Antarctica for some testing or whether you go there for, that's a totally different story. Huh? To go to the moon, you can do it, huh? Even in summer break, 1 week, back and forth, it's possible. So I believe to go to Mars is a challenge. We will go there, but it will take some years. And therefore I propose, let's go together, not back to the moon, but forward to the moon, meaning not in space race, but in cooperation worldwide. Each and everyone is asked to contribute whatever he or she would like to contribute, whether it's a public or private institution, whether it's human or robotic. That's the idea, to have an open, free and open access, and I call it therefore the Moon Village, which is not some single houses, a church and a bar. It is the idea of working together, not in one project, but to work together on this, in this area. The Americans were a little bit shocked. You see here, CNN, the Europeans have suddenly some idea. But anyhow, there's some ideas also with telescopes going on the far side of the moon, which is not the dark side. The far side is as bright as the near side. But go there and build some telescopes out of the material of the moon. You can have a very nice view into the universe without all the disturbance of our earthly radiation. The Americans immediately said, yes, now we will participate, we will build some roads. I said, but not the speed limit of America. So. And Elon Musk, who always said Mars, 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 in 2007 he said, yes, it's clear, but I will build the moon base Alpha. So he is now also supporting the moon. And Jeff Bezos, the other one, another American, he's saying a city on the moon. Of course, the Americans are always a little bit bigger. We are more, the Europeans are more modest with the village. It's okay. This was a reaction of a Scandinavian company saying, we have also something to deliver. But what is a real message from my side, this is, I quote Mahatma Gandhi, our ability to reach unity and diversity will be the beauty and the test of our civilization. And therefore what we need is visionaries for the future. We need to fascinate people, then they are inspired and they are motivated to create the future, and we all need that. Thank you very much for your attention.
You mentioned the identification of ships. The same applies to airplanes.
Yes.
Good. Why did...
Yes, good question. I know the question.
Okay. What's the answer?
The answer is that we do not have a system, and what he meant is why can it be that the planes are suddenly disappearing and we don't know, and humans are dying and we don't know where. This was something which we really personally touched very much. We have this possibility, it's called ADS-B. There is a special receiver, but there are not enough satellites in space that you can get each and every plane at any time. That's a problem. If you have enough of these, and we are trying to put in as many satellites as possible, these receivers, so that we have that information. But unfortunately, that special case, in all the special cases from these planes, we do not have the data, unfortunately. But the technology is there, we only need enough receivers. While with the ships they are much slower, it's not so difficult.
Okay, thanks.
But the question, excuse me that I interrupted you, is always my problem.
Any other questions?
Please.
Are you planning to put Galileo satellites around the moon as well? So
did I show this picture? No, I did not show it. Huh? In our earlier discussion, I had it. I had a picture showing some navigation satellites around the moon. We are thinking about the next generation of satellite navigation to use it in space. Whether this means automatically that we have Galileo satellites orbiting the moon, or whether we can use even also the ones orbiting the Earth, that's another question. The farther you go, the better it is. You have also some satellites over there. But what we also have a company within this Moon Village idea, which is now developing a communication satellite for the moon, for all the communications on the surface. So satellite navigation on planets is important for the future, and we are looking into that. Please.
Hi, yes, we were discussing the other night the...
Before coming here, you were already...
We were discussing the speed of space travel, you know, there was achievable by humans in the future. And then there was some new stuff, laser-driven or something. Could you elaborate on that, please?
Okay, I ask all the scientists tell me. So, first of all, some 150 years ago it was believed that if you go faster than 20 kilometers per hour you will be dead because your heart was... So, I don't think that there is, from this point of view, a limitation for humans. However, there's number one, the speed of light, which unfortunately Einstein defined that this is not possible to reach because the mass is getting more and more. Of course, it was not Einstein, it is the physics behind it. And the second thing is you cannot have an infinite acceleration, and that means you cannot go for a long period, let's say with 6G. That's for the body not possible. Short period possible. So I don't know whether 100, 1000 is really a limitation in that direction, but I'm sure there is some practical limitation because it takes too long to reach this velocity. So the better solution would be Interstellar, the movie Interstellar, to go to a wormhole and then you are there. But so far, even the best scientists don't have it. Even Stephen Hawking did not find that solution finally. Fabio, help me. Okay, so it was all right what I said?
Absolutely.
Good. So,
will we have a community living on Mars in the foreseeable future?
Personally, I say always, I'm not looking forward to to colonize Moon and Mars. Because if you colonize Moon and Mars, you will live in camps. And this is not nice. You cannot tell me that it's nice to live in a camp when you have the beautiful Earth. There is one organization, one company in the Netherlands which is offering a not a round trip, but a one-way trip. Single trip. I don't support that. I don't support because remember the face of Samantha. The Earth is so beautiful. Why should we? And I think even it's dangerous. Stephen Hawking said that. That's the only point where I disagree with him. He said, maybe because we destroy our Earth, we have to leave. I say it the other way. We should never destroy our Earth because leaving is an option. there is no planet B. And therefore I'm not in favor of that. I'm sure humans will go to Mars, they will go even beyond, but I don't see that we will colonize Mars as a second Earth.